All right, this is 11.1 part 2. So we're going to do some applications with that circumference and arc length and stuff like that. So the circumference, we remember, is 2 pi r, or the diameter times pi. All right, so let's do. So here the dimensions of a tire are shown. To the nearest foot, so a nearest foot means the whole foot, how far does the tire travel when it makes 15 revolutions? So essentially we want to know how far it would be for a whole revolution, because that's how far it would go, and we want to multiply that by 15. So what is the diameter? The diameter would be this whole thing. So the diameter is going to be 5.5 plus 15 plus 5.5. So the diameter here is 26, and it's 26 inches. So keep that in mind. The dimensions it gave us was inches, and it's asking it in feet. So here the diameter is 26 inches. So what's the circumference? Well, the circumference formula we have with the diameter is diameter times pi. So 26 times pi, this is why I like the pi button. I'm actually just going to leave it as 26 pi, because then the distance is 15 times 26 times pi. So we put pi in the end to round as little as possible. So 15 times 26 times pi is 1225.22. Remember, that's in inches. So to get to feet, we divide by 12. And 1225.22 divided by 12 is 102.1, and it wanted the nearest feet. So 102 feet would be our answer. So it's 1225.22 inches, but that's 102 feet. All right. This next one is kind of a composite of two shapes. So the curves at the end of the track are 180-degree arcs, so they're exact semicircles. So they're exact semicircles. And the radius is a little bit different for each one, because like a track, there is an inside and an outside. So for the inside track, it's 36.8 meters of radius. The outside track is 44.02 meters. So this is saying how far does the inside runner travel to go once around the track, and then how far does the outside runner go? Now round to the nearest tenth of a meter, so that's 1 decimal. So essentially we're doing these circumferences because it makes one full circle if you add them together, but we're also adding in this rectangle. So it's both 84.39 on both sides. So let's do the inside runner first. So the inside runner is going to do 84.39 plus 84.39, so when they run both of those straight parts, plus a diameter of, a circumference of one full circle with that smaller radius. So 2 pi, and the smaller radius is 36.8. You put that whole thing in your calculator, you're going to get 400 meters. Is that right? That seems too exact. Well, let's see. We have 84.39 plus 84.39 plus 2 pi times 36.8. Yeah, so if we were to round to one decimal place, it would actually round to the 0. So the inside runner is going 40 meters when they do one revolution. The outside runner, so they're going that 84.39 and 84.39 as well, because that straight part is the same on both. They're just doing a circumference of a slightly larger circle. So this time 2 pi times 44.02. So I'm actually going to use that function on my calculator where I do second enter and it kind of retypes the problem for me. So I can just change that last part, 44.02. And they went 445.36. So if I round that to 1/10, that is 0.4 meters. So if you're on the outside track, you do one revolution around the whole track, you're going to go a little over 45 meters farther. All right, you've watched both videos. Now you can do your you can do your 11.1 homework.